Right, okay, here we go. So session 18. I'm recording this after Christmas, so Happy New Year for those of you who are in this cohort. We're going to start with the last chapter in the book, which is Matrices, something new. A lot of you wouldn't have seen this before. You might have seen the film The Matrix, which is a fantastic film, and not really know what a matrix is. So we're going to introduce what that is, and then we're going to sort of do some basic addition and multiplication using matrices today. So let's get cracking. Right, okay, so a matrix is basically, it's a good way of ordering data. So matrix is quite simply a good way of ordering data and putting values in. It's essentially a table, really. So it's essentially a table. Okay, so let's look at an example of what a matrix might look like, and it might be a way, you might have seen it, any football fans out there, if you look at the table of any sort of football table, that really is a matrix. So you could have something like here, teams along the column, and my team Watford, you might have Man City, Chelsea, Tottenham, etc., etc. And you might have the games they've won, the games they've lost, and the games they've drawn. And the numbers in there, that would form a matrix. So say if Watford had won 5, lost 1, drawn 0, Man City 4, 2, 1 maybe, Chelsea 3, 0, 4, and Tottenham maybe 2, 3, 1. So that there is, I've created a matrix, and the information around the outside is just explaining what the matrix is. And this particular matrix, we call this, we say this has got dimensions, this matrix has dimensions 4 by 3, because it's the rows by the columns. And there's 4 rows, 3 columns, so this is a 4 by 3 matrix. That's what we say, it's a 4 by 3 matrix. Okay, so that's a little bit of an intro in what matrices are. They're there to sort of hold data in quite an ordered way. Right, we're just going to do some addition first. So adding matrices. And we might just go straight in with an example. So add okay, so we might be asked to compute this matrix plus the other matrix. Now just for practice, both of these matrices are going to be 2 by 2 matrices because there's 2 rows and 2 columns. And simply when you add them, you literally pair up. So you do 2, add 2. Now these individual things, these are called elements in a matrix. So the individual numbers or items in a matrix, they're called the elements. So the first top left is going to be 2, add 2, which is 4. The next one's going to be 3, add minus 1, which is 2. Then 1, add 0, which is 1. 4, add 3, 7. So that would be my answer, and that's how we add matrices or subtract. Now note, you can only add or subtract matrices with identical dimensions. So you couldn't do this thing here, it's something like a 1, 2, 3, 1, add 3 minus 1. That you cannot commute. You cannot compute that. It will just give you would just not be able to do it. It does not have it does not have the right dimensions. This dimensions is a 2 by 2. That one, it's rows times columns 2 by 1. They're not compatible for addition. Okay. So that is what we do with addition. Multiplying, not quite as straightforward, but not too bad once you know the rules. Multiplication. Okay, and I'm going to just give 3 matrices here. So A equals, this will be applied throughout the whole of these examples. So let's say matrix A is like that. Matrix B, let's call that 1, 2, 3, and let's call matrix C 3, maybe minus 2 there, something like that. Okay, so we've got 3 matrices. I'm just going to write the dimensions underneath, just practice 2 by 2, that's a 2 by 2. This is a 2 by 1, okay, because it's 2 rows, 1 column. Okay, so a few examples. Best way to do multiply matrices is through an example. So e.g., calculate 2A. Okay, so 2 lots of matrix A. And how you do this? Okay, well, it's just 2 multiplied by 4. And when you're just doubling a matrix, you just double every element in that matrix. So it's going to be 2 times 2 in the top left, 4, 2 times minus 4, minus 8, 2 times 1, which is 2, and 2 times 3, which is 6. So just multiplying a matrix by an integer there is not too bad, okay? It's when we have to multiply them together. So A, B this time. So matrix A multiplied by matrix B. I'm just going to write that out again. So A is 2 minus 4, 1, 3. And matrix B is 2, 3, minus 1, and 0. Okay? And we're multiplying these two together. And what I do here is I multiply the row by the column. Okay? So row by the column. So what I mean by that, and I'm going to give myself a fair bit of space, I'm going to do some practice on this as well. It is 2 times 2, so it's top left times top left. So it's 2 times 2, add minus 4 times minus 1. So you go along the first row, multiply it by along down the first column, okay? So that is my first one there. Right, if I want to do the bottom left element, I'm just going to make this even bigger. Bottom left element would be, let's pick a different colour here. Let's maybe call this one pink. It's going to be pink 1 times the red times that red 2, and then it's going to be 3 plus green 3 times the orange minus 1. Okay, just take a little while to digest that. I'm just going to put some more colours in here. So we've got some, maybe a purple there, and we'll just have a black. 0. Okay, so the last top right is top column, top row, sorry, top row. So it's going to be 2, the red 2 in the top, times the purple 3, add the orange minus 4 times by the 0 there, in the 0 in the bottom right. Okay, and bottom right, you're going to get the pink, you're going to get the 1 times by the purple, add the 3, the green 3 there, times by the 0 again. And then we just compute all of that together. I'll put a gent, so you're going to get 4, add 4, so you're going to get 8, 6, add 0, 6 there. This is 2, minus 3, minus 1, and here's going to be 3, just 3 there. So the answer to that, multiplied by that, is 8, 6, minus 1, 3. Right, let's do in general, because I appreciate that's quite a lot to take in, although I would recommend writing that example down. So in general, if you have 2 matrices, we'll just do 2 by 2 to start with. So A, B, C, D multiplied by E, F, G, H, that will give you a matrix of A times E plus B times G, and then on the bottom there, CE, add DG, and then over on the top right it would be AF, add BH, and then CF, add DH. So make sure you've got that down. That is basically how we multiply matrices together. Okay, there are some uses for that. There's ways why we have such a strict system in place so every mathematician knows what they're doing when they multiply matrices together. Okay, let's look at a e.g. 2. So let's multiply these two together. 2 minus 4, 1, 3, and multiplied by just 4, 1 this time. So it's just this is a 2 by 2 multiplied by a 2 by 1. Okay, so I'm going to do 2 times 4 plus minus 4 times 1. Okay, that's on the top, and then it's the bottom row times that column again. So it's 1 times 4 plus 3 times 1. So my answer there would be 8 minus 4, so 4, and then on the bottom it's going to be 4 plus 3, 7. So it's going to be 4, 7. Right, now you can only multiply matrices. You can only multiply matrices together if they have the right dimensions. Now, what I mean by the right dimensions is these two values must be the same. So must be the same. Okay. So, e.g., we cannot necessarily, or we can't in this case, 4, 1 multiplied by 2. This is not computable because that's a 2 by 1 matrix, this is a 2 by 2 matrix. These two values here, these two dimensions are not the same, therefore we cannot multiply the matrices together. Now if they are the same, like up here, this is the resulting matrix dimensions, which is useful. Resulting matrix dimensions. Okay, so this is a 2 by 1. It's the resulting matrix dimensions. Which brings me to my final point in terms of multiplication. So in matrices, AB is not necessarily equal to BA. You can if you multiply AB together, you're not necessarily going to get BA. Sometimes true for some specific cases, but not always. In fact, mostly they will not be the same. This is different to numbers. This is different to numbers because obviously 3 times 4 is the same as 4 times 3. But that's not the same in matrices. Right, we're going to do an exam style question now, and then you're going to do some practice. Exam style question. So you've got something like 3a minus 2, 1. And we're going to multiply that by 2 minus 2 minus 3b, and that equals 12, 2 minus 7, 0. And the question is find A and B. Find A and B. That is the question, probably quite a few marks in a further maths paper, this. Okay, and you might want to pause the video at this point and actually have a go yourself using the tools we've just done. But I'm going to go ahead and answer how we would do this question. So the left-hand side, let's look at the left-hand side and let's actually multiply this out, the left-hand side. So my top left element is going to be 3 times 2, 3 times 2, add A times minus 3. So add A times minus 3. Okay, that's the first top left. Top right will be 3 times minus 2. 3 times minus 2, and then A times B plus A, B. Bottom left is going to be minus 2 times 2 plus 1 times 3. That's a minus 3, sorry. 1 times minus 3. Okay, and bottom right will be minus 2 times minus 2, add 1 times b, 1 times b. Okay, right, let's just tidy that up a little bit. So you get here 6 minus 3a. Top left, you're going to get minus 6 plus ab. Bottom left, you're going to get minus 7, which is a good check. In a minute, you'll see this is going to be 4 plus b. And this all equals the matrix 12, 2, minus 7, 0. And you can now just compare elements. So that element has got to be the same as that element. So 6 minus 3a equals 12. And I solve that like a normal equation. So what's that going to be? 3a equals negative 6, a equals negative 2. And then if I find one just with b's in, that one's a good one to check. So 4 plus b equals 0. B is going to equal negative 4. And I mean, I could do a check on the others. Minus 7 equals minus 7. That's good. So minus 7 equals minus 7. And then this one, a quick check on here. Minus 6 plus AB, minus 6, that's going to be plus 8, does equal 2. So I know I'm pretty accurate with that. So those are my two answers there. Okay. Now, matrices have extremely powerful uses in maths and in real life applications, which we're going to come on to a few later on in future sessions. But it's really important you just know how they operate to begin with. So you need to know how they are used in maths, and then before we can start looking at the applications, which we're going to do later on. Right, what I wanted you to do is a bit of practice on this. So I want you to go to page 240 and page 241. Okay, and I want you to do question 2, just the first and last part. So first and last part for question 2, question 3, question 5, and then I want you to do all of the whole of question 8. Okay, so it's questions 2, 3, and 5, just the first and the last part, and then the whole of question 8. If you feel like you need a bit more practice on that, please do more than that. But that's really what I expect you to do this week. Okay, well done guys, thanks for listening, and tune in next time for a little bit more on matrices. Well done.